Hello everyone here, this is Eason from Think Academy Singapore. Today we are going to talk about the melt time meeting, which is a distance word problem. We know that in distance word problems there are some meeting problems, which is there are two positions A and B, right? So two people here, they start from A and B separately, walking in the opposite direction, and they meet in the middle. This is what we call meeting. Each time when we see a meeting case, we should always take a research on the sum of their distance, right? Maybe I should emphasize this one to be blue, to be more accurate. So when we calculate the sum of distance they traveled, it's easy to find that, they together traveled a whole journey of AB. So we can name the length of AB as an S, which means the first time they meet, together they traveled the whole distance of S. But then, if they keep traveling together, and when they reach the vertex B and A, they would return and continue the journey. So then, maybe they will meet for the second time or the third time. So, let's look at the second time. When the second time they meet, still we look at the sum of their distance they traveled. So in the diagram, we can easily find out that together they traveled 1, 2, and 3. 3 times the length of AB, which is triple S. That is, for the second time they met, they traveled totally 3 distance of S. So what if they keep traveling again and again and again? So, there is a routine that we can say that for the n times of meeting, right? For the nth time meeting. So they should travel together with 2 times m minus 1 times s. It can be understood as for the first time they traveled only 1s to meet each other, but after the first time, then each time they should firstly, travel an s backward and travel another s forward. So, after the first meeting, so each other meeting will take them 2s to be meeting together, right? So, we know now the relationship of the meeting time and the total distance they traveled. Now, with this relationship, we can solve some melt meeting problems. First of all, let's look at the 2017 problem. It's a 4-point question. It's a very typical melt time meeting problem. So there are two people, G and H, right? They traveled from A and B, and the first time they meet at a point 64 meters away from A. So let's draw a picture here. A, B, right? And then this is the first time they meet. Okay? And then when they met at this point, they kept working and turn around when reach the vertex. And then they meet again for the second time. Now we know two distances here. So the first maybe C here, right? The first place they met, is 64 meters from A. And the second place they met is 168 meters away from A, right? So we only know these two distances. Then we should find the distance between A and B. So, how to solve this problem? The key point is they meet for 2 times, then in a meeting problem, we should always study the distance in sum. So the first time, the sum of distance is then x is a total AB, right? But now, there is a 64 here. So what is this 64 meters? It's the distance which George has traveled, right? So for George, he will travel 64 meters, right? This is the first time. But what about the second time? For the second time, as shown in the picture, they together traveled for 3 times of s. So let's compare this. The sum of distance, the first time is 1s, the second time is 3s. So the sum of speed remains unchanged. That means that the ratio of time is equal to the ratio of distance. So distance is 3 times as before, which means the time of meeting is also 3 times as before in total. But it's also for George, right? And then looking at the George, for the first time, George traveled for 64 meters. And then what about the second time? So we know that the time is 3 times of before, then George's speed remains unchanged, which means George has traveled also 3 times as before. So in the second time they met, George should have traveled 3 times 64, right? Which is 192 meters. Then we look at that back picture. So the first time, this is the 64, and when George travel and turn back, so all the highlighted lines represent the 192 meters. So what else do we know? We know that the second time of their meeting, this point is 168 meters from A. So we highlighted this part, and then this 168 meters. When putting them together, it's surely that it will equal to 2 times the distance of AB is 2 times S, which means 2 times S will just equal to 192 plus 168. Then adding them together, then divided by 2, we can have 1S equals to 180. So this is a typical question about melt-time meeting. So we are considering the sum of distance they travel together both in the first meeting and second meeting. Then, the sum of distance determines the ratio of time. The ratio of time determines, how far George or Heidi, in this term George, right? So how far George has traveled. Also a ratio of distance. Then we can solve the problem easily. So the melt-time meeting is something about the ratio. And the ratio comes from the sum of distance. And that's the key point. Okay, now we have solved the easy one. We may move to a more difficult one about this type of question. So it comes in the 2060, right? So it's a 5-point question. So now in this case, right, we have the speed of Linda and Samir, which is 3.5 and 4.5. They travel between X and Y. And the first time they meet at point A, the second time they meet at point B. And the distance between A and B is shown as 200 meters. So we need to find the distance of XY. So it seems not that easy to solve, right? As we know the speed, but we do not know the time. And there is no time given. And we don't know how to use this distance between 2 positions of meeting. So there are some different ways to solve the problem, maybe by algebra, I think. But the easiest way to solve this should, again, according to the melt time meeting method, that is, by calculating the sum of distance they have traveled. So now, different from the formal question, we know the speed here, but we do not know time. But without the time, we at least have the ratio of speed, right? So the speed is 3.5 and 4.5, which means the ratio of speed is 7 to 9, right? 3.5 to 4.5, right? Then, we know the ratio of speed. Then we should know that if they traveled a total distance of xy, right? They travel total distance together. We should know that the distance they traveled separately should also be 7/9, as meeting comes in the same time, right? The time is the same. And then we can just use the ratio of speed to represent the total length of xy. We let the xy be 16u. So a total distance is 16u. Then when they finish a whole race, the whole xy together, when the sum of distance is 16u, then for Linda and Samuel, right? And the sum. So when the sum is 16u, we know that the distance ratio between Linda and Samuel should equal to their ratio of speed, which is 7/9. So Linda should travel 7u and Samuel should travel 9u, right? So this would be the first time they met, which means we can determine the position of A here. So A is here, 7u from X, 9u from Y, right? Okay, then again, we know that the second time they meet each other at point B. Then for the second time, again, we can calculate the sum of distance they have traveled, which is 3 times 16u, which would be 48u's, right? They have traveled 3 times the distance of xy. And by then, we can calculate the distance Linda has traveled, which should also be 3 times 7u, is 21u's. So, if Linda has traveled 21u's to meet Samuel for the second time in point B, so how long actually has traveled? We know that the total distance is a 16u, right? So this is 16u, and she should travel another 5u's to reach point B. So which means now we can find the position of point B is 5u away from point Y. Then we know that the total distance is 16u. So 7u here, 5u here. So what is the distance between A, B? So it should be 16 minus 7 minus 5, which is 4u here. And we know that distance between A, B is 200 meters. So 4u equals to 200 meters, which means 1u equals to 50 meters. Then we have xy to be 16u's. So the distance of xy is then solved as 50 times 16, which means 800 meters. Now, that is the way we solve this problem. Of course, algebra can solve it, but I think this is the easiest way and the method we should all master about the melt time meeting problems. Okay, that's all for today. See you tomorrow.